Good morning, my dear students. Today we are going to start with a very important chapter that is called derivative. The reason why this is important is in class 12 you will get around 35 marks from this particular topic. So today we are going to learn the basics of derivative. So this topic is called calculus. Calculus is basically derivative or differentiation and integration. In class 11 I am going to teach you derivative or differentiation. So let us begin. This is called derivative or differentiation. Differentiation means you are breaking the function into smaller parts. Differentiating. Is that clear? So you can differentiate n number of times depending on the function. So once again, what is differentiation? Derivative means you are breaking the function into smaller parts, whereas integration means you are accumulating smaller parts and making it big. So derivative and integration are just opposite to each other. So in order to understand derivative, the first thing you need to understand is what type of question can you expect. So we have to deal with two types of functions. One is called explicit function. Explicit function means a function in which there are two variables and one variable is expressed in terms of another variable. For example, we say that y equal to fx. So that means y is expressed in terms of x. So y is on the left and x is on the right. So since y is expressed in terms of x, y is called your dependent variable and x is called your independent variable. So given an explicit function, what we do is we have to differentiate the dependent variable with respect to the independent variable. That is, we differentiate y with respect to x. So in other words, dy by dx is the rate of change of y with respect to x. Because as x changes, y will also change. So I'll just explain how y is called the dependent variable and x is called the independent variable. I just take an example. Let us say y equal to x squared plus 2. This is an explicit function because y is expressed in terms of x. So if I have to plot this, what am I going to do? I am going to take random values of x. Let us say x is 0, so y becomes 2. When x is 1, y becomes 3. When x is minus 1, rather when x is 2, y becomes 6. So from here you can see the choice of y depends on the value of x. So y is called the dependent variable and x is called the independent variable. Is that clear? So that is why given an explicit function, we differentiate y with respect to x, or in other words, we find out the change in y brought about by the change in x. So that is called dy by dx, and this is called differential coefficient, or in other words, differentiating y with respect to x. Got it? So this is the first type of function which you can expect. This is called an explicit function, and the second one is called your implicit function. Implicit function means both variables x and y will be together. So x and y will be together. So this is an implicit function. So in this case also we find out the change in y with respect to x. For example, x squared plus 2xy plus y squared equal to 0. So this is an example of an implicit function. So my dear students, as you can see, we've started with the chapter calculus, and calculus has two parts, derivative and integration. So we are starting with derivative or differentiation. So differentiation means what? First, I explained the type of question which you can expect. There are explicit and this is implicit. Explicit means y is expressed in terms of x. So y is called the dependent variable and x is called the independent because the choice of x is random. Whatever value of x you put, according to that the value of y changes. So we differentiate y with respect to x. So what does this mean? The rate at which y is changing with respect to x. So this is called differential coefficient. Is that clear? Now moving on to the properties of derivative. So property 1, so as you know, we have to differentiate with respect to x. So properties of derivative. So property number 1, d by dx. What does this mean? We are differentiating with respect to the variable x because x is independent. So c into fx. That means whenever there is a constant in a function, the constant comes in front and you simply have to differentiate the function. So this is property number 1. So you are going to use this whenever there is a constant and a function. I can give you an example. D by dx of a constant, let us say 7, and when I say function, I mean algebraic x, exponential e, log and trigonometry. Is that clear? So let us say I take sine x as a trigonometric function. So in this case, what we are supposed to do is the 7 comes in front and you simply have to differentiate sine x. That means break sine x. Is that clear? So whenever there is a constant, the constant term comes in front. Okay. Number two, whenever there is a plus or a minus sign between two functions and all the functions will be in terms of x. Keep that in mind. So whenever there is a plus or a minus sign between two functions, then what we have to do is we simply have to differentiate them individually, separately. Is that clear? So this is property number 2. I can give you example. Let us take two functions. One is algebraic. Algebraic means x to the power anything minus, let us say, log x. So I need to differentiate two functions. There's a minus sign in between. So what am I going to do? I'm going to differentiate them individually. So d by dx of x cube minus d by dx of log x. So this is called, this is whenever there are two functions and there's a plus or a minus, you differentiate them individually. So this is property number 2. Property number 3, this is called product rule. This is called product rule or u into v. Suppose instead of fx and gx, I'm writing u into v. So there are two functions, u and v. So if there's a multiplication, then you don't apply the formula directly. So please, dear students, keep in mind that before you apply the formula, you have to use the property first. Is that clear? Formula means we are differentiating, means we are breaking the function. So product rule says d by dx of u into v becomes, you cannot apply the formula directly, you have to apply the formula one at a time. So how is it done? Keep u constant, differentiate v, plus v constant, differentiate u. So this is called product rule, u into v. I can give you an example. Example number 3. D by dx of, let us say, exponential e to the power x into, let us say, a trigonometrical, that means tan x. I have to differentiate this. So this is your u and this is your v. There I will give you formulas for e to the power x, I will give you formulas for tan x, but you cannot apply the formula directly unless and until you use the property. Why? Because there's a multiplication sign, so you have to use product rule. So this becomes u, this becomes v. Tell me the rule, but write down the value. The rule is u. U means e to the power x, d by dx of v, that means tan x, plus v means tan x into d by dx of e to the power x. So this is called product rule. What is it called, everyone? Product rule. So the last property is quotient rule. Quotient rule means whenever there is a division sign, d by dx of u by v, then we cannot break the function directly, we have to use property, and the property is the denominator square, v square into v d by dx of u minus u d by dx of v. So this is called quotient rule. I can give you an example. D by dx of, let us say, x square divided by e to the power x. So this is u, this is v. The rule is v square, like e to the power x whole square, then e to the power x as it is, d by dx of x square minus x square into d by dx of e to the power x. So these are the 4 properties which you have to apply before you differentiate the function, means before you break the function. Is that clear? So just go through it. Property 1, constant and a function, constant comes in front. If there's a plus or minus sign between two functions, then you differentiate one at a time. If there's a multiplication sign, use product rule. That is one constant, differentiate the second, then second constant, then differentiate the first. And if there's a division sign, then the denominator square, then denominator into d by dx of u minus u d by dx of v. So these are the four properties which you have to use before you differentiate the function. Now I will teach you how to differentiate or apply the formula. Apply the formula. Okay, apply the formula means differentiate. Differentiate means break the function. Okay, formula number 1 says d by dx of x to the power n. That means whenever the power of x is n, then what is going to happen? The power, I told you, you are breaking it, so n comes in front and x to the power n minus 1. So this is the formula. So my dear students, please keep in mind that the faster you study, the faster you understand the property and the formulas, it will be easy for you, because a major portion of the syllabus in class 12 will be basically calculus, that is derivative and integration. Unless and until you understand derivative, you will not understand integration. So the first thing you need to know is the property and the formulas. That is why the first class I am explaining the formulas and the properties, so that we have no problem when we start doing the problems. So once again, x to the power n, whatever be the power of n, whatever be the power of x, since we are differentiating, means we are making it small, then this is the formula. The power comes in front, then x to the power n minus 1. I can give you an example. Example number 1, suppose d by dx of, let us say, x to the power 7. Then since we are breaking it, the power has to reduce. So what is going to happen? 7 comes in front, x to the power 7 minus 1 is 6. So this is the differentiated value. Differentiation means we are breaking the function. See, the d by dx vanishes. So this is formula number 1. Formula number 2 says d by dx of e to the power x, exponential will be e to the power x itself. That means x will not come in front, because this is an exponential function. Is that clear? So d by dx of e to the power mx, that means if there is a constant term, the constant term comes in front and e to the power mx. So whenever you differentiate an exponential function, the function remains same. Is that clear? It's just that if there is a constant term, the constant comes in front. I can give you an example. E to the power 7x becomes, 7 comes in front, so it becomes 7 dot e to the power 7x. Is that clear? So this is formula number 2. Formula number 3, d by dx of e to the power x. That means, see the difference between formula number 1 and formula number 3. Formula number 1 says the base is x and the power is a constant. And formula number 3 says the base is a constant and the power is x. So it's going to be a to the power x log a. The formula is going to be a to the power x log a. So similarly, d by dx of a to the power mx is going to be m dot a to the power mx into log a. To make this thing clear, I can give you an example. Formula number 1 is x to the power 4. Base is x, power is 4, so it becomes 4x cubed. 4 comes in front, you reduce 1 from the power, it becomes 4x cubed. And formula number 3 is 4 to the power x. That means base is a constant and the power is x. Then the formula will be 4 to the power x log 4. So this is how you apply the formula. That means you are breaking the function. Okay, so this is formula number 3. Formula number 4, d by dx of log x. d by dx of log x is 1 by x. And finally, formula number 5, d by dx of a constant is 0. So these are the 5 formulas which will help you differentiate an algebraic function. The moment you see x, whatever be the power of x, it gets reduced by 1. Exponential function, e, log function. So these are the 3 functions. These are formula for 3 functions. Now one more function is left, that is trigonometry. We will discuss with later. So these are the 5 formulas. Based on this, I will give you some particular cases based on formula number 1. So the moment you see differentiation of x, you are going to write 1. Differentiation of x is 1. How? I just explain it out here, so you don't have to do it again and again. So next time you see x, you directly write down as 1. So differentiation of x will be d by dx of x. X's power is 1. So I am going to use formula number 1. What's going to happen to 1? 1 comes in front, x to the power 1 minus 1. So 1 x to the power 0. So x to the power 0 is 1. So differentiation of x is 1. Similarly, d by dx of 1 by x. This is very important, everyone. Pay attention. So whenever you see x, you know that you have to use formula number 1. But in this particular case, x is in the denominator. So what do? I take it to the numerator, so it becomes x to the power minus 1. So what happens to minus 1 comes in front. So n minus 1. So minus 1 x to the power minus 2. Make it positive, 1 by x squared. So differentiation of 1 by x is minus 1 by x squared. And the third formula is d by dx of root x. d by dx of root x will be equal to again. So d by dx of root x can be written as x to the power 1 by 2. So again, what will happen to 1 by 2 comes in front. X to the power 1 by 2 minus 1. So 1 by 2 into x to the power minus 1 by 2. Since it's negative, you take it down. So x to the power 1 by 2. So 1 by 2 x to the power 1 by 2 means root x. So what's the differentiation of root x? It is 1 by 2 root x. So these are the three particular cases. Is that clear? So once again, my dear students, as you can see, differentiate means you can expect two type of functions. One is explicit, means y will be on the left, x will be on the right. The other one is x and y will be together. Is that clear? Now after that, you are going to break the function because we are differentiating. That means differentiation means we are finding the change of y with respect to x. Is that clear? So differentiation means we are breaking the function. So before you apply the formula, you have to use the property. Once you apply the property, then you can use the 5 formulas plus the 3 particular cases. Now we got one last set of formula, then we are done with this particular chapter. Then we can start off with problems. So I want every one of you to copy these formulas in your maths fair copy and memorize it, because as I've already told you, maximum marks weightage in class 12 will be from this particular topic. Now we have already discussed the formula for algebraic, exponential and log. Now we are going to discuss for trigonometric function. Okay, so let us start. So number 1, d by dx of sine x. So differentiation of sine x will be cos x, semicolon. D by dx of sine mx. If there is a constant term, the constant comes in front. So differentiation of sine is cos mx. Next, differentiation of cos x. If differentiation of sine is cos, then obviously cos is sine, but will be minus sine x. So similarly, d by dx of cos mx will be minus m sine mx. Formula number 2. Formula number 3, d by dx of tan x will be equal to sec square x, and d by dx of tan mx will be, m will come in front and differentiation of tan is sec. So sec square mx. Formula number 4, d by dx of cot x will be, differentiation of tan is sec square, then obviously differentiation of cot will be minus cos x square x. So d by dx of cot mx will be minus m cosec square x. Formula number 5, d by dx of, we have sec x will be sec x tan x. So similarly, d by dx of sec mx is going to be m dot sec mx into tan mx. And the last formula is formula number 6, that is d by dx of cosec x will be minus cosec x into cot x. So d by dx of cosec mx will be minus m cosec mx into cot mx. Is that clear? So let me tell you one more time that these are the main formulas. Out here only if there's a constant term, the constant comes in front. Is that clear? So I have given you 5 formulas plus 6 is 11 formula plus 3 particular formulas. So 11 plus 3 will give you 14 formulas. Are very important for you. for you to understand the chapter on calculus. Is that clear? So next time next class I'll start with the problems. So I expect you all to copy all the formulas, the properties, and memorize it. Thank you so much.